So last year, one of the world's most important weather centers did something, well, something truly radical. They put an AI forecast into operational service, running it right alongside their gold standard physics-based model. And just to be clear, this isn't some test run. This is the new reality of weather and climate science. Okay, let's dive into this.
You know, it all boils down to one massive question. Are we on the verge of trusting machines to understand Earth's climate system, maybe even better than we do? I know, it sounds like something straight out of science fiction, but the data is starting to tell a very, very different story. And we're not talking about a small tweak here. The European Center for Medium-Range Weather Forecasts, or ECMWF for short, is already reporting that its AI model is beating traditional methods on key metrics. For example, it's improving the tracking of tropical cyclones by up to 20%. That is a huge leap in accuracy.
So, here's the crucial point. This technology has officially moved out of the research lab and into the daily forecast pipeline. The AI revolution in climate science isn't coming. It's already here.
So in this explainer, here's what we're going to do. We're going to break down this radical new forecast, dig into the incredible speed revolution that's making it all possible, and look at the real-world wins that are happening right now. Then we'll hit pause for some important risks and reality checks we can't ignore, and finally, we'll sketch out what an AI-assisted future for our planet really looks like. All right, let's start with that groundbreaking shift. By 2025, the ECMWF made its AI forecasting system, they call it AIFs, fully operational. I mean, this was a massive vote of confidence and a completely new way of thinking about the weather.
And the momentum here has been building incredibly fast. Just think, in 2023, Huawei's Pangu weather model first showed it could outperform traditional methods. Then, boom, in 2024, DeepMind's GraphCast comes along and just blows the doors off, beating the state-of-the-art models on a staggering 90 to 97% of metrics. And that all culminated in that 2025 operational launch, really marking a brand new era.
So you're probably wondering, how is all of this even possible? Well, the answer lies in what we're calling the AI speed revolution. See, it's not just that these models are more accurate in some areas, it's that they are doing it at a speed and a cost that was pretty much unimaginable before. And that changes everything.
Okay, what's really interesting on this slide is the fundamental difference in approach. See, traditional models are, well, they're computationally hungry. They have to solve the incredibly complex laws of physics across these massive grids, step by painful step. AI models, they do something totally different. They learn the patterns directly from decades of past weather data. You know, think of it like a chess grandmaster who studied every game ever played. They don't need to calculate every single possible move. They just recognize the patterns instantly. And that shift from calculating to pattern recognition, that's the whole game changer.
And this chart just says it all, doesn't it? What used to take massive supercomputers hours, or in some cases even days to figure out, can now be done in minutes, on a single piece of hardware. This isn't just a small step forward. It's a complete paradigm shift in how we do forecasting. And the efficiency gains are just as staggering. I mean, get this. Platforms like NVIDIA's Earth-2 are reporting that their AI models can be up to 10,000 times more energy efficient. Now, why does that matter? Well, cheaper, greener computing power isn't just about saving money. It means we can go from running one single forecast to running thousands of possible scenarios at once. This gives us a much, much richer understanding of risk, letting us prepare for a whole range of potential futures, not just the one we thought was most likely. So, let's see how all this speed and efficiency actually translates into real-world wins that we can see today, because this isn't just some academic exercise. It's unlocking immediate, practical applications that can actually save lives and save money. The fastest payoffs are in something called nowcasting. That's predicting weather in the immediate future, like the next 24 hours. This means we get better, more localized warnings for floods and storms. It lets us manage our energy grids way smarter, gives insurance companies more accurate risk models, and helps us plan long-term infrastructure better. And we already have proof this works. Take Google's MetNet family of AI models, for instance. It's been shown to consistently outperform the existing U.S. operational models for short-term rain forecasts. This is exactly the kind of high-resolution, immediate information that helps communities get ready for what's coming. But what about the really long-term stuff? You know, climate, not just short-term weather. Well, that's where a really cool new tool comes in, AI emulators. These are AI models trained not on real-world data, but on the outputs of our most complex, highest-end climate simulations. Basically, they learn the rules of those simulations and can then mimic them at a tiny fraction of the cost and time.
And check this out. Here's a statistic that really puts the power of this into perspective. An AI emulator at the University of Washington recently simulated 1,000 years of climate variability in just 12 hours. The supercomputer version of that exact same simulation, it would take about 90 days. I mean, this just opens the door to stress testing or adaptation plans across centuries of possible climate futures, something that was simply way too expensive to even think about doing before.
But hang on, we've got to be realistic here. With all this power comes a really huge question of trust. What are the blind spots? Can we really trust what is essentially a black box with decisions that affect our planet's future? So let's be clear, AI models are not perfect. They can struggle with rare, fast-evolving, extreme events that maybe weren't well represented in their training data. Think of those rapidly intensifying bomb cyclones. They also still have some difficulty nailing the precise intensity of major storms. These are known issues, and they mean we have to be cautious.
So what's the solution? Well, the crucial point is that the answer isn't to throw out the old models or the human experts. No way. The winning formula is a hybrid approach. You combine the incredible speed of AI with the rigor of those physics-based models, and you keep a human forecaster in the loop to interpret the results, spot anything that looks weird, and make the final call.
And to make sure we're not just buying into hype, the scientific community has developed these independent benchmarks. Projects like WeatherBench2 give us a standardized apples-to-apples comparison for all models, both AI and traditional, using the exact same data and the exact same metrics. It's an absolutely essential guardrail for making sure that progress is real.
So where does this all lead? Let's zoom out and look at the AI-assisted future and how this huge technological shift could create a fundamentally more resilient economy for all of us.
It basically creates this powerful economic flywheel. First, the cost of running a single forecast just plummets. And because it's so much cheaper, the number of scenarios you can run just explodes. And when you can explore thousands of possible futures instead of just a handful, well, the number of expensive mistakes you make in everything from city planning to energy investment goes way, way down. Ultimately, this isn't a story about AI replacing humans. Not at all. It's about extending our own abilities. The AI climate scientist is a new, incredibly powerful tool in our toolkit. So the debate is no longer about if these tools will model our climate. The real question, the one we all have to think about, is how we, as a society, will choose to use this incredible new insight to build a safer, more resilient world.